Okay, so you guys should have a notebook. You should have a calculator. All right. We're going to take a look at an idea called an arithmetic sequence today, or an arithmetic sequence, some people call it. I'm going to show you two questions today from the 2019 state test. There was no 2020 state test because we weren't here in the spring of last year. So this would be from the year prior. It's the only thing, or the most recent thing that I have for you in relation to this. We're going to look at one right at the very beginning, and then we'll look at another one later on, and we'll actually come back to the one that we started class with. Okay, so kind of going to move around through this idea. We are going to be looking, though, at just a couple different ideas. One, what is an arithmetic sequence? Can I identify them? Can I use them moving forward? All right. But I'm going to start you with this today. So this is from the 2019 test. This was question 12. All right, on that test. I'm going to give you about a minute or so. Okay, see if you can figure out what's the first number in this sequence. That's what they're asking you. I want to give you a whole lot of background on it. Okay, just kind of what can you come up with? What do you think? We'll come back to this exact same question at the end of class. So if you're able to come up with an answer right now, I want you to put it down on your paper. We're not really going to talk about it right now, though. If you don't, it's okay. No, like you don't fail because you didn't come up with the answer yet. That's not a big deal. I'm just interested on what you're thinking. So just give me a minute to try that. Quinn, do you have a calculator? Okay. Andrew, do you have a calculator? Okay. Just as long as you have one. You think you have something? Okay. Well, we're not even going to discuss answers right now. How many of you think you have an answer right now? Okay. How many of you just not even really sure where you're going with this? Okay. Does more time at this point right now help you? Okay. So there's no point to just continue to wait. Okay. That's fair enough. I'm glad you recognize that. Some people would say yes, regardless of whether that would do anything for you or not. All right. So here's our two goals for today. One, first of all, what is an arithmetic sequence? That's one thing we got to figure out. All right. And then number two, how are they related to linear functions? Because if you think about this chapter, everything we're doing is a linear function. So how does this play into that path? All right. So those are our two objectives, so to speak, for today. Some words we may run across. Recognize any of those? Yeah. Okay. What is it in your words? What's a sequence? Okay. Yeah, you'd agree with that? A way something happens. Okay. Like a specific order. Okay. Ah. Okay. A chronological order. I like that. What does chronological mean to you? I'm interested here. Yeah. Okay. Good. I mean, chronological does mean time order, so that's good that you think of it that way, and that you didn't think of it some other way. Okay. All right. How many of you have ever done this during a storm, where you watch the strike and then you count and you wait and you listen for the sound? How many of you have done that before? Okay. And what's the thought? What's that tell you, or supposed to tell you roughly? Okay. And so if I counted to two, typically we would say the storm is 2 miles away, right? We usually give like a 1-to-1 relationship there. All right. So if you started to kind of list those things out, like how long and the distance, how long and the distance, how long and the distance, they would start to form what's known as a sequence. Okay. Or maybe some of you think of that as a pattern, maybe sometimes. though honestly, those two things aren't quite the same. All right. So here is kind of a cutout of that. Do you know the number that's underneath that box right there? Right. I know. You don't know, right? So I'm going to tell you. If the storm time is 1 second in difference, that's going to relate to 2/10 of a mile. So storm's moving pretty quick. Do you know what's underneath the next one? How many of you think you have a guess of what's underneath the next one? Right, and I think you will. What do you think it is? 0.4. If that's true, would you be able to tell me everything else in this pattern? Okay, so if that's true, can you tell me what's in that spot right there? Okay, 1.2. Good. Right. What did you do to get from where we were to down there? What did you do? You count by twos? Sure. I would agree. That's how I would have done it. Multiply? Am I adding or am I multiplying? I'm adding. How much am I adding each time? 0.2, right? So every one of these was adding 0.2 every single time. When they do the same thing every single time, that's called an arithmetic sequence. Okay? So when you add the same amount every single time, or if you subtract the same amount every single time, what's created is called an arithmetic sequence. Okay? So for example, if I had these ordered pairs, like let's say 1 and 4, 2 and 10, 3 and 16, do you know what the next one would be? I hope the answer is yes. Nick, what's the next one? On the y side, it would be a 22, and on the x side, it would be a 4, right? What's happening in those y values right there every single time, Tyler? Adding 6, okay? And over here in the x's, they are adding 1. Would this form a straight line? How come? How come, okay? Um, if you subtract 1, that would go back to 0. This one wouldn't. It would go to -2. That just means it's not a direct variation. Those had to go through the origin. But would it be a straight line, Andrea? Yeah, yeah, right. There's a constant change in there every single time, right? And so actually, these numbers right here 4, 10, 16, 22, the next one would be 28, right? They're an arithmetic sequence. They're just going up by the same amount every single time. These values over here 1, 2, 3, 4, 5, 6, right? They're also an arithmetic sequence. If you can establish a common difference, or what we call the letter D. Algebra is just riddled with letters, right? Always something standing for something else, right? Yeah, right. If you can establish that common difference, what you're saying is then there is a sequence here. All right. There is what's known as an arithmetic sequence. So the first thing we're going to do is we're going to look at 3 of them. All I want you to do is tell me yes, they are, or no, they're not. Okay. If they are, you should be able to extend it. If it's not, then obviously you can't. Okay. Yeah, that's what we're going to look at. Okay. This is what your book would kind of show you, but it's kind of the same idea, what we just talked about. So those differences can be positive or they can be negative, either way, up or down. All right. So how about this? Is that an arithmetic sequence? How do you know? Going up by 4 every time? So if that's true, then you should be able to tell me what the next 3 numbers are. So, Ben, what are the next 3? You're good so far. 25, 29, and add 4 to that, you get 33. 33, right? How long could you take that? Forever. Why? Because ultimately those sequence values build straight lines, which is why you could continue that pattern on forever, right? How about this one? Yeah, but I just watched what you did. Wouldn't you be able to tell me what the next one is? I, I just watched Quinn do this. No, I'm not. I'm being no. I, right. What were you doing? Yeah. Yeah. Good. Okay. So the next one would say go down by 5 and then go down by 6. Okay. Is it a sequence? No. It's a pattern. 100% there's a pattern, right? But is there a common difference here? And you would say no, right? Think about that like a set of stairs to go down 2 units, then down 3, then down 4, then down 5, then down 6. I mean, that would be a wicked set of stairs. Well, I mean, if you thought about like the first one went down 2, then the next one went down 3, then the next one went down 4, then the next one went down. I mean, that'd be pretty interesting pretty quick. All right. I don't know what would be worse, trying to go up them or down. Up, you just walk right into them. Down, you'd fall. So, I mean, whichever your goal is. Okay. So, that is, I mean, there 100% there's a pattern there, but there definitely is not a common difference. So, therefore, there's no terms to come after that, not by the definition of a sequence. What about the last one? So, Logan, what's the common difference? What is it? Subtract 3. So, if that's true, then Carly, what are the next 3 numbers? Yeah, good, good. Right. And again, could we continue this? Absolutely, because they're doing the same thing every time. All right. Okay. That's a great picture. All right. How many of you have ever seen something like that before, where you have a variable or a letter with a small number next to it? Have you ever seen something like that before? Oh, the answer is yes. Like literally last week. Uh, y2 minus y1 over x2 minus x1. What do those little 2's and 1's represent? The second set or the first set. So really what they talk about is their position, okay? And what these are called, they're called subscripts. We read them like that. We would say like a sub 9 if we were talking about the 9th term, or a sub 3 if we were talking about. Well, because if you listen to A9, you would probably think like that, or Battleship, right? Right? A9. Ooh, sorry, miss, right? But so a sub means it's a subscript or a lower. So it's not a multiplication, but we're just talking about position. What you looking at? Yeah, right. Just give me like this. Okay. Now, take a look at this here. Would you consider 3, 5, 7, and 9 to be a sequence? Yes? Okay. All right. So then let me ask you this. We hide that enough? All right. If 3, 5, 7, and 9 are the first, second, third, and fourth, can you tell me what am I asking for here? I'm asking you for the 20th term. So take a second. I don't care if you finger count, if you steal it from your neighbor. What do you think the 20th term is in this sequence? You already have an answer? All right, hold on one second. Some of us haven't even thought yet. Hold on. Just wait a second. You think you have it?
I'm probably wrong.
Okay. All right.
Wait, do you mean like 9, 20 after 9, or 20 starting
From the 3.
from the 3? Okay.
You think it's this?
Yeah.
Okay. All right. Okay. It's a guess. It might be. Are you finger counting? All right, I'll leave you alone. Sorry. But what if I just started yelling random numbers? Would that mess you up? Yeah. Is that what you think? Okay. So let's start here. First of all, every one of these numbers is an odd number, and we're adding 2, which is going to keep them odd. So if you have an even answer, unfortunately, that can't be possible. It's got to be an odd number. All right. Carly, you think you have it? 39. Okay. 41. 43. All right. Now listen, those are all in a row, right? 39, 41, and 43 are 3 terms that are all in a row. So chances are maybe one of those is right.
I got
90. Now, first of all, that's an even number. So I'm pretty sure that 90 is an even number. 31. Okay, that's an odd number, so maybe it's a possibility. All right. Carly's going to finger count it again to make sure. Oh, are you? That is toxic. It is. All right. So the correct answer is 41. Okay. Now, okay. So let's talk about 2 things. Number 1, how many of you, first of all, try to find your answer by doing +2, +2, +2, +2 until they got to what they thought was the right number? How many of you went that route? Okay. Did anybody do anything different than that? And got, okay. And so you thought your answer was 40? Okay. All right. Find out it's really close, right? Okay. Okay. So did you do that prior to knowing the answer was 41 or after knowing the answer was 41? Okay. All right.
I did 20 times 2, and I got 40, and then I add 3 B's first.
Okay. All right. I really like that idea. We are going to use it, but we're going to tweak it just that because you were off, right? But you were really close. Oh, okay. Uh-huh. Uh-huh. Right. Right. Sure, so it's 16, yeah. Uh-huh. Yeah. And that got you to 41. Okay. So, all right. So let's look at this in 2 ways because Jack and Aiden, you guys are both really close to saying the same thing. Jack initially said, I'm going to do 2 times 20 because you're asking me for the 20th spot. But then why did you add 3 on? Okay, because we started with 3, right? Aiden looked at it as and said, well, I already know the first 4. That means I got to do 16 more. And so 16 times 2, you said was 32, and then you added 9 on, and it got you to 41. You guys are like so close to one another in your statements. We got to tweak yours just a hair, and then both of these statements truly will line up with each other. Now, the reason we're going to do this, and we'll come back to this question here in a second, but look at this problem here. This is also from the same test in 2019. They give you the first 4, and they ask you for the 60th. Why do you think they pick such a large number for you guys to try to find the answer to? I don't even know if they want you to work, I'll be honest with you. I don't know the real answer, but in my gut, I think they picked this for a reason.
So you know how to like find the number by not adding.
Okay. I guess I'm more of a cynic than you guys. Here's my opinion. I think they picked a number high, like 60, because if you try to do this stuff, counting on your fingers, chances are you'll do what? You'll mess up, right? Yeah. Or if in your calculator you're hitting like plus, 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 plus until you try to get there, will you mistakenly not do enough or maybe do too many? I really honestly in my gut believe that that's why a number this high was chosen. Okay. But we're going to use the model that you two guys were just talking about. And then it won't matter what number they give us. We can find out any spot right away. All right. So here's what I want you to think about. We have to know, let's go back to this problem for a second. We have to know in this problem, where are we starting, where are we going, and what are we doing every single time? All right. So think about this. We know the numbers 3, 5, 7, and 9. And we were asked to find, stop it. We were asked to find, yes, the 20th. A sub 20, right? I was yelling at me. I wanted that line to move down, but it was all attached, okay? So if I'm trying to find the 20th term, where did we start? Started with the number 3, right? It's definitely got to be a part of my problem. Jack then said that in addition to the 3, he did 20 times 2. Okay. But that answer, if you put it in your calculator, gives you how much? 43. Change something in here so that this number comes out to be an answer of 41, like we wanted, instead of 43. What needs to change? Well, no. Subtract. So turn this into an 18. All right, Kyler? That's okay. You told me I was going to add 3 to this because it was where I started. But if I started with this one and then went 20 more spaces, I ended up too far. Yeah? Do you know? Well, if you put a 1 here, it's because we ultimately knew the answer was 41. So it's like, let me just add a 1 instead of add a 3. Logan? Ah. If I already know the first term, I don't need to go 20 more to get to my answer. I only need to go 19 more to get to my answer. Well, because if I'm looking for the 20th term, give me the first one plus 19 more after that. It's exactly what Aiden said. He started with the 4th one and then said, give me 16 more after that because the 4 and the 16 gave him the 20. Here, it's the first one and 19 more gets me to 20. So if I said to you, I'd like to find the 35th term. Give me the first one, which is 3, and then give me how many more after that so that I get to where I want to be. 34, 34, sorry, 34. And I'm going to do 34 times 2. Why am I choosing to multiply by 2? Because it was going up by 2 every time. Okay? And I don't, what's the answer to that? 34 times 2 is 68 plus 3 more, 71. And it would not matter what number they asked me for. I could use this path to get me to that point. Does that make sense? So let's do this, because we need to come up with kind of something a little general here. So here's what we're going to say. Go. Will you not move? Let's go over there. All right. We are going to write what is known as the nth term formula. Okay. Now, when we say the nth, we're just really meaning I don't care what number you ask me for. I can make this work no matter what. Okay. So instead of saying the 20th or the 35th, I'm going to say the nth, meaning fill it in with whatever you want. Okay. This 3, why did I put a 3 in my formula? Because it was what? The first. How do you represent the first? You would say, no, a sub 1. Good. So this spot here, a sub 1. Now, in this top one, I put a 19. In the second one, I put a 34. What am I going to write here? Do you know? No, it's not going to be. Listen, here n was a 20, but I put a 19. Here n was a 35, but I put a 34. Here it's just an n. What am I going to put there? N minus 1. Good. No matter what n is, I want 1 less. What's that? Why is it so hard? In two seconds ago, you told me exactly what was going to go here, right? Because in a moment when I ask you to find the 60th term of something else, you're not going to want to go, on your fingers. Because it's not always going to be a 3. Why is it not always going to be a 3 in the first spot? Because whatever your pattern or your sequence starts with, that's what's got to go there. It's got to be the first one in that sequence. Whatever spot you're looking for, that's got to be 1 less, whatever it is you're looking for. And this number that was a 2 isn't always going to be a 2. Why was it a 2 in that problem? Because I was going up by 2s. But what if I'm going up by 5s? Then this number now has to be a 5. What if I was going down by 3? Now it's got to be a minus 3. This thing right here had a name. No. Started with it's 2 words. First word was a C, and the second word was a D. The common difference. And the letter we give that is a D. Good. We don't need to yell, but thanks. If you don't have this written down, you need to have it written down because you're going to need it in your homework tonight. Okay? No. Okay. It's right there. It's right here. It's right here. Okay. So we're going to do this one right here, which was on is that test question. Okay. So take a second, following this thought process about if I'm looking for the 60th term, then what you're really looking for is a sub 60. Because that's the one I'm looking for. So you need to be able to figure out 3 things. Where did it start? What's it doing every time? And how many more in this path do I really need? Exactly. Oh, it's like that.
I might be wrong.
You're right.
Yay.
What you got? Yes, very good. Very good. Thanks. Okay. Fill these things in. What's A1? What's the first number? Okay. So you should be putting into this piece, what's A1? It's 27 plus what number's going inside the parentheses?
59.
So one less, so 59. And the value that we're calling the common difference is a 5. So put a 5 in there. If you multiply 59 times 5 and you add 27, you get 322. Okay? Now, could you have started at 27 and added 5 until you got there? Absolutely. The point is when that number there gets to a certain, I guess, degree or level, doing it by hand might not be your best idea, right? Okay. So if you do not have this formula, you are going to practice it tonight in your homework. So make sure you have it. Okay. Last question. We're going back to where we started. So here's an example of a sequence. Okay. That's a little bit more because you're missing some things along the way, right? You don't necessarily have all the pieces. But if you recognize or understand that an arithmetic sequence has to add or subtract by the same amount every time, then I think you should be able to figure out where this goes. And maybe if you're struggling a little bit, think like this. We don't know the first one, but we know the second one. We don't know the third, but we know the fourth. Right? And we don't know the fifth or the sixth, but we know that the seventh is that. Okay? Yeah. That's what it's doing every time. That's not what that number is.
I have no clue.
Well, we're looking for what's in the first spot.